Okay, today we're going to go over linear differential equations. For now, we're going to be working just for 9.5 solely with problems that are in this form. Remember, not everything is a linear differential equation. Not everything is a separable differential equation. So far, we know how to do separable. Now we're going to learn a second one. And those of you that go on to differential equations, you'll work with other differential equations. So for now, for us, a linear differential equation. So a linear differential equation is one that can be written in the form y prime plus p of x times y is equal to q of x, okay? So this is going to end up being pretty important in the problem, so we'll keep an eye on that. This p of x right here, okay? So first thing we want to do is we want to make sure that we can identify if something is a linear differential equation. So I have y prime plus x squared y is equal to 2. So all we have to do is we look up here and we say, is this problem in that form? If it is, then it is linear. So we're going to say, yes, this is a linear differential equation, right? It's in the right form. And p of x is equal to x squared, right? So that's that. For this one, it's almost a linear differential equation. So what I have to do first is I have to divide by x. And the reason I do that is you guys notice there's a 1 in front of there, right? We have a 1. Oops. We have a 1 in front of our y prime. In this case, we have an x in front of our y prime. So for all of the problems we do, we always want a 1 in front. So we're going to divide everything by x. So this will cancel. And this will become y prime minus 1 over x times y is equal to 3e to the x over x, okay? So is this in the form? Do we have y prime plus or minus, or I guess you could say plus some p of x times y is equal to some q of x? Yes, we do. So this is linear. Oops, let me do this. Linear. And we know that p of x is equal to negative 1 over x. Make sure that you always bring the sign with the p of x. So if it's a plus, then it's a plus 1 over x, or if it's a negative, then it's a negative 1 over x. Whatever is in front of that y is your p of x, okay? So just make sure you do that. And that's what this little note is down here. It says there must always be a 1 in front of the y prime, and the sign in front of p of x goes with the p of x. So whatever you call it, if you call it 1 over x, you better make sure that the sign that was in front of it comes with it when you go to work with it. So here's kind of the thing we're going to do. We're going to have this 8-step process for solving linear differential equations. So what we're going to do is we're first going to make sure the equation is linear and in the correct form, meaning that like if it doesn't have a 1 in front, we're going to divide by that first. That's kind of normally the thing I see most students get wrong is they sometimes, so make sure y prime has a coefficient of 1. So a lot of students forget that part, okay? So make sure that you do that. You have to identify p of x, and then once you get p of x, you have to integrate it. And then you multiply the entire equation by whatever you found when you integrated p of x. You have to integrate it by e to that, okay? You rewrite the left and the right-hand side of your equation, okay, to e integral of p of x times y, y prime. Integrate both sides of the equation, solve for y, and then solve for c. So this is kind of a long process. So I'm going to go through it one by one with you on this one. So let's go through this problem. So hopefully you guys are pausing the video and taking a minute to write these down on a separate sheet of paper, or in your notes, I should say. And then we're going to try this problem now. So it says solve y prime minus 3y is equal to e to the x with y of 0 equals 3. So this we know right away. This is our initial condition. So they gave us initial condition. So that means we will be able to use step 8 and solve for c. So first thing that we do is we're going to go up here and it says make sure it's in the correct form. Is this in the correct form? Does it have a 1 in front? Yes, it does. So we're good. Is it linear? Yes, it is. It's y prime minus some or plus some p of x times y is equal to some q of x. So it is in the right form for us, okay? Now what it says is, so we're going to go and you don't have to write this out when you're going through and doing it, but to practice, you might want to do it for the first few. So 1, yes, correct form. Okay. Step 2, p of x equals -3, right? It's whatever's in front of the y, okay? Step 3 says, let's see what step 3 says, integrate p of x. So I'm going to take the integral of 3 dx equal to 3x, okay? And I know it's supposed to be 3x plus c, but you don't need to put that for now. We'll get that later. There'll be another plus c when we integrate again, okay? So now we have 3x. Wait a minute, it's a -3x, sorry about that. So this is a -3. So then step 4 says, what? What are we supposed to do with step 4? Multiply the entire equation by e to the p of x. So whatever we got in step 3, which was -3x, we're going to multiply our entire equation by it. So I'm going to write out y prime minus 3y equals e to the x, and I'm going to multiply this whole thing by e to the -3x, e to the -3x, right? Because that's what I got right here. I got -3x, and it says multiply by e to whatever you got. So let's clean this up. So this will be e to the -3x y prime minus e to the -3x. Ooh, let's fix this a little. If we distribute that, this will be plus 3 e to the -3x y, and this would become e to the -2x when we clean this up. That sounds right. Let me double check. Why did I get a plus sign right here? This is supposed to be a minus. Yeah, because when we distribute this, they'll stay minus. So we have that so far. Okay, looks good. Now here's kind of the rub, okay? So far, this is what we have. Okay, so that's what we have so far. Step 5, now this is kind of the one that needs a little, it says rewrite the left-hand side of your equation to be e to the integral of p of x times y, and then the whole thing prime. So what you're gonna do is you're gonna say e to the -3x. So it says, write it as e to the whatever, whatever you got from integral of p of x times y. And then you take it and you put it to the prime. And you're saying that that entire thing is the left-hand side, okay? And this is e to the -2x. So I need you guys to understand. I took this and rewrote it as this, right? So just so you understand, that's what I did, okay? Now here's the thing. How does this work? How is that legal to even say? How can you just replace that? Well, in reality, what that is, if you took this problem, and you don't have to do this, I just want to show you guys the scratch work for it. If you took this problem and found the derivative of this, wouldn't this be a product rule? Wouldn't it be e to the -3x y, e to the -3x times -3y plus e to the -3x times the derivative of y, which would be y prime. Well, if I rewrote this and put this guy over here and this guy over here, this would be e to the -3x y prime minus 3y e to the -3x. Or actually, let me write it cleaner. So if you notice, this is the same as this, and this is the same as this. So in reality, what you're doing is you're telling someone, another way I could rewrite the left-hand side is I could rewrite it as something before I took the product rule of it, before I took the derivative of it. So it's like set up to be differentiated, but you're saying I haven't done it. So this is not necessary to show. I just wanted to show you guys where all this came from. So hold on quick. For some reason, the eraser was working. So you don't need to do all of that. But what you do need to say is you need to say that this is equal to this now, right? We rewrote our equation. And that would be step 5. So step 5 says rewrite the left-hand side of your equation to be this, e to the integral p of x times y prime, and then integrate both sides of your equation. So in step 6 now, I'm going to integrate e to the negative 3xy prime equals the integral of e to the negative 2x dx. Now, we learned that integration and differentiation are inverse operations of each other. That's what the fundamental theorem of calculus was talking about, part 1. So we're just left with e to the negative 3xy equals, now this is a little u sub, so we're going to do a little u sub. We're going to say u equals negative 2x, so then du equals negative 2 dx, divide both sides by negative 2. So we now have negative 1/2 integral e to the u du. So this is e to the negative 3xy equals negative 1/2 e to the u, but u in this problem was negative 2x, so negative 2x plus c. Okay. So hopefully you're on board still. Again, the jump from step 4 to 5 is kind of when you have to trust the process. But if you don't trust it, then think about this would be the product rule of that. So you can go through and convince yourself of it. You do it a few times and you start trusting that it works. And again, this only works because it was a linear differential equation. It wouldn't work on every different equation. It works on these, okay, because of the way we're setting them up. So now it's for y. So now I have to divide both sides by e to the negative 3x. I'm just looking at my, it says in step 7, solve for y, right? So I'm just going to go through and do that. So this is e to the negative 3x divided by e to the negative 3x divided by e to the negative 3x. Okay, so that's gone, that cancels, it becomes 1. We have y equals, well, I believe this would be negative e to the x over 2 plus e to the 3x times c. Okay, so this is technically our answer. This is step 7. I think I forgot to write it. So step 7, we solved, so I guess this is kind of 7a, and this is part B, where we divided, okay? So now we have, basically, this is our differential equation. We have the answer. We now have that y is equal to negative 1/2 e to the x plus c times e to the 3x. So technically this would be done. However, they gave us an initial condition of y of 0 is equal to 3. So we can do step 8. Not all of the problems have a step 8 because you aren't always given initial conditions. We know that y of 0 is equal to 3. So that means that I can say 3 is equal to e to the 0 over 2 plus e to the 3 times 0 times c. Let's go over here. We kind of haven't used up a lot of room. So we have 3 equals 1/2 plus c. So this would be what? 7/2 equals c. So if I just subtract it over, so that should be, oh, not 7/2. I think that's wrong. 2.5, which is 5/2, right? No, maybe I was right the first time. No, I was right the first time. C equals Oh, I see why I messed up. You guys see way over here, this is a negative, right? I forgot this negative right there. So that's why. So this is actually 3 plus 1/2 equals C. So then it will be 7/2 equals C. So this is my C. So then our true answer, y equals negative, I guess we could write it as e to the x over 2 plus e to the 3x, 7/2 e to the 3x. And that is our official correct answer. Okay, so it's not easy. Linear differential equations do take some time. So this is how I teach them. There are other ways to do it. I learned this from a colleague of mine, and so it seems to work really good. So hopefully you guys get the hang of it. Let's try another one. This is something you really have to practice. This isn't just something that you just pick up and you just know. So let's do example 3. So let's take a look at this one. We have x, y prime plus y is equal to the square root of x. Okay, so no initial condition this time. So we can just kind of go through it. So take a minute, pause the video, look at your 8 steps. This one will only require 7 because there's no initial condition. And why don't you guys try to go steps 1 through 8, kind of looking back at your notes, trying to do it. Okay, so take a minute to do that. Okay, so hopefully the first thing you did is you divided by x. Remember, this was step 1. Step 1 said you had to have y prime by itself. So we now have y prime is equal to, y prime plus 1 over x, y equals, that'll be what, 1 over x to the 1/2? Or we could even write it as x to the negative 1/2. Okay. So what does step 2 say? Step 2 says we have to identify p of x, and then we have to multiply, we integrate p of x. So step 2 says identify p of x. We know that p of x equals 1 over x, okay? And this is going to lead us to step 3, which says to integrate 1 over x dx, which is actually the natural log of x, right? So we get the natural log of x for this. And then step 4 says that we have to multiply e to this. So we're going to multiply the entire equation by e to the ln of x. So we're going to do e to the ln of x times our entire equation, which would be y prime plus 1 over xy equals x to the negative 1/2. Now, hopefully you guys are kind of seeing that e to the ln of x is really just x. So what we're actually multiplying by is just x. So we get x y prime plus y equals x to the 1/2. Does this look familiar? This is basically the original problem. Okay, so as it turns out, they pulled a fast one on us. We actually had the original problem was already in the right form, but it's really hard to recognize. So, you know, if you see it, go ahead and recognize that. You can kind of jump right ahead to step 5, but I didn't recognize it, you know, the first time I did it. Obviously now I've done this problem a few times, but when I first did it, I didn't recognize it. I said, oh, look, it's the exact same problem. So now we're going to reduce this to x, y prime. Okay, that's what step 6 says to do. Or I'm sorry, step 5 says reduce it to e to the p of x. But e to the p of x, the integral of p of x is just x. So that's what I did. All right, this is just plain old x. Okay, plus, is equal to x to the 1/2. So as you can see, I'm now kind of working my way towards step 6. Step 6 now says to integrate both sides. So this will become xy. This will become x to the 3/2 times 2/3, right? Plus c. And now we're going to divide everything by x. So then this will become y equals 2/3 x to the 1/2 plus x to the, plus c times x to the -1. And this would be our final answer. So if we wanted to, we could go through and kind of label stuff, right? We could say, well, this was kind of step 1, right? This was step 2, this was step 3. Step 4 says to multiply, so this was step 4, right? This was step 5, this was step 6, this was step 7. So we did our steps. Again, you guys don't have to go through and name it 1, 2, 3. I'm just showing you the process, and then you guys have to make sure that you go through all of these things when you're doing it. But you don't actually have to go 1, 2, 3, 4, 5, 6, 7 and write it down for me, but it is a way to keep it organized for you, okay? Let me see what else I got for you guys. Okay, so we've got this one. Ooh, this one looks tough. Okay, so this one looks tough. Let's see what we got here. So this will be example 4. So example 4 says solve 1 plus x squared y prime plus 3xy equals 6x. Okay, so the first thing you notice is you are not allowed to have that 1 plus x squared in front of the y prime. So take a minute, pause the video, divide by that, and then identify p of x, integrate p of x, and then multiply by e to that p of that integral of p of x. Okay, so get started on that. Okay, so hopefully you guys did what I'm doing right here. 1 plus x squared, 1 plus x squared, 1 plus x squared, cancel, cancel, becomes 1s. So now let's see what we have left. We have y equals, oops, I keep doing that, y prime plus 3x over 1 plus x squared times y equals 6x over 1 plus x squared. Okay, so is it linear? First of all, yes it is, because it's y prime plus some p of x times y is equal to some q of x. So it is definitely linear. Okay, remember, not everything is linear, but obviously in this section it's going to be, because that's what we're testing you on. And then we identify our p of x. So p of x equals 3x over 1 plus x squared. And then from there, you guys know that in step 3, you have to integrate that. So I'm going to integrate 3x. I'm going to take the 3 out right now, guys. I'm going to put it in the front. This will be x over 1 plus x squared dx. Now, some of you might be thinking right now, because you see that 1 plus x squared, oh, that's arctan. But remember, we don't need that because of the x in the numerator. This is just a nice u sub. So this is just going to be u equals 1 plus x squared. Du equals 2x dx. Divide both sides by 2. Cancel, cancel. So this is what dx is worth. So now we're going to have 3 integral. Oops, that's really 3 over 2, right? 3 over 2 integral of du over, sorry guys, I don't know what happened there. Du over u. But we know that that is actually 3/2 ln of the absolute value of u, but u is 1 plus. Okay. So we have 1 plus x squared. I'm sorry, 3/2 ln of 1 plus x squared. That is what we get when we integrate our p of x. Now we have to take e to all of this. So now we have to multiply e to the 3/2 ln of the absolute value of 1 plus x squared, okay? And we have to multiply that by our equation. So our equation was y prime plus 3x over 1 plus x squared y equals 6x over 1 plus x squared. Okay, so this times that. Let me do this actually. To the 3/2. Okay, so this is pretty rough. This is definitely a difficult problem. However, there is something that we could have done from the beginning. Let's see here. We could have taken this, we could have said e to the 3/2 ln of the absolute value of x, 1 plus x squared. And I could have rewritten that. Let me do this in green, actually, you guys. Let me show you how we could clean this up a little bit. We're going to do e to the 3/2 ln of the absolute value of 1 plus x squared. But we know that that is actually the same as e to the ln of the absolute value of 1 plus x squared to the 3/2 power. Remember, you're allowed to put the exponent up top. Now this, the e to the ln, will wipe each other out, and we're left with 1 plus x squared to the 3/2. You get rid of the absolute values when you use that property. So that means I could actually erase this now. And instead of using that, I could use this cleaner version of 1 plus x squared to the 3/2 power. Well, that looks much better than e to the 3/2. But remember, they're the same thing. This is the same as that. They are identical. So we have 1 plus x squared, identical in worth, I should say. They are equivalent. So we can write this. Now, remember, here's the rub. When you go from step 5, so we're going to go back up here. It says rewrite the left-hand side of your equation to e to the p of x, or the integral of p of x times y. So I'm just going to trust it. I'm going to trust that that's what it is. So my e to the integral of p of x, which was this guy, right, is, so I'm just going to rewrite this as 1 plus x squared to the 3/2 power times y to the prime, right? That's what the technique tells us to do, right? And that has to equal, well, let's see here. This can cancel a little bit, right? Right here, this cancels with a 3/2 power. This is actually to a 2/2 power, which is a 1. So this would just be a 1/2 power now, and this is just 1. So this will be 6x times 1 plus x squared to the 1/2 power. Okay, if you just do some cleanup on that. And then step 6 says we integrate both sides. So this cancels with this, and we're left with 1 plus x squared 3/2 power y is equal, well, I guess we're going to have to integrate that again. Let's see here. So yeah, I think we're just going to have to let, I'm going to rewrite this real quick. So I'm going to take the 6 out, and this is going to become x times 1 plus x squared to the 1/2 dx. But that is really 6. This is u equals 1 plus x squared. Du equals 2x dx. Divide both sides by 2. So we have du over 2 is worth an x dx, which is what we have. So I'm going to do 6 over 2 times the integral of u to the 1/2 du. So this will become 3 u to the 3/2 over 3/2 plus c. So now let's kind of bring it back a little bit. We're kind of getting all over the place here. Let's kind of rewrite. So the left-hand side, let's bring it down here. The left-hand side is 1 plus x squared to the 3/2 y. And that's going to equal, what is that, 2. U, we said, was 1 plus x squared. So this is 1 plus x squared to the 3/2 power plus c. And all I'm doing, you guys, is I'm looking at this right here, and I'm cleaning that up and turning it into that right there. Okay. So I think we have it. Now we can divide by 1 plus x squared, 3/2 power, divide by 1 plus x squared, 3/2 power, divide by 1 plus x squared, 3/2 power. And let's see what we have left standing. So y equals, well, this cancels with this, and that just leaves a 2 behind, plus c over 1 plus x squared to the 3/2 power. And that would be our final answer. And we're good. Okay, so that's definitely one of the harder problems. I think we had to use U substitution twice. If you guys go back and look, we had to use U substitution quite a few times with this problem. Not an easy problem at all. This is definitely a more difficult linear differential equations. And hopefully, I hope you guys are noticing that linear differentials seem a lot harder than separable differential. Separable differential are, I feel like, the easier of the differential equations. Linear seem to kind of step up the difficulty quite a bit. Okay, so let's try another problem. Let's call this example 5. So let's try something a little bit, I think this one has another little cleanup in it that will kind of, it's something you guys have to get used to. Xy prime minus 2y equals x squared. Yeah, so first thing you guys should have noticed, divide everything by x. That's your go-to move. You have to recognize if you can do that first. So this will become y prime minus 2, minus 2 over x, y equals x. So now you identify your p of x, and you should say that it's 2 over x. And if you do this, you're going to get it wrong. So everything you do from here on out will be wrong because you messed up on your p of x. Remember, I said that the sign has to come with. So we have to remember to put that negative 2 over x right there. So then when we integrate this, we're going to take the integral of negative 2 integral of x to the negative 1 dx, which is negative 2 ln of the absolute value of x. Now remember, we're going to then do e to this integral, negative 2 ln of the absolute value of x. Okay, but this cleans up even better to be e to the ln of the absolute value of x to the negative 2. Right, so you got to really keep that in mind, that if you want to do this little trick or this little, I guess, technique, you have to take this power and you have to put it back up here if there's an ln, because you want to be able to wipe those guys out and you'll just get x to the negative 2, which is just 1 over x squared. Right, so now we know that we're about to multiply everything by x to the negative 2, or you can just think of it as 1 over x squared, whichever way works better for you. So we're going to take y prime minus 2 over x, y equals x, and I'm going to multiply this by x to the negative 2 by x to the negative 2, because remember, x to the negative 2 is really that. Okay, e to the integral of p of x. Okay, so now this becomes x to the negative 2 y prime minus, let me see here, that's actually what, 2x to the negative 3y equals what is that? X to the negative 1. So far, so good. Now remember, we're trusting the process because we identified it as a linear differential equation. It said that we should be able to rewrite the left-hand side simply as this. It said e to the integral, let me write it for you guys, e to the integral of whatever p of x was times y, and then you prime it. That's what I'm doing. I'm trusting that, okay? If you don't believe it, then you have to convince yourself, and you have to go through and do the product rule on this problem, okay? And if you do the product rule, you'll get this right here, okay? So you know that it's a good, fair rewrite, okay? And then this is x to the negative 1. Now we integrate both sides. Okay, and let's see what we have here. This will just become x to the negative 2y, right? And then this will become ln of the absolute value of x plus c. Okay, now we're going to multiply both sides by x squared, or you could divide by however you want to see it. I'm just gonna, you could divide by x to the negative 2, but that's, I could just multiply by x squared and this would cancel that, right? So I'm gonna multiply this by x squared. Y equals x squared ln of the absolute value of x plus c times x squared. And this would be my solution to my linear differential equation. Okay, so that's kind of a good little step into linear differential equations. There's more problems out there. If you guys take a differential equations class, you'll obviously cover much more than this. But yeah, be on the lookout for the next video. I'll go back to chapter 9.4 where we'll talk about the, I forgot the name of it. Oh yeah, models for population growth, which is, we're going to use the logistic model. We'll do a few problems on that, and then we'll call it a day. Okay, that'll be the next video. So the next video will be pretty short. But hopefully you guys kind of can follow the 8-step process, and you may need to talk to me about this. This is by far the hardest thing in chapter 9 that we've done so far. Okay, I'm going to end the video. Thanks for watching.